Gravitation tutorial. We'll go over the gravitation equation, the gravitation example, and the calculators. Why the calculators? Doing gravitation problems is often difficult as much because of the calculators as it is because of the concepts. This is a quick review of the gravitation equation. F sub g is g m1 m2 over r squared. Now these different elements of the equation are pretty intuitive, except for a couple of things. G is kind of scientists' way of expressing the fact that in nature the gravitational force is very weak. It's a universal constant. It's always the same for any two objects in the universe. These masses are for any two objects in the universe, great or small. This F is the force between the two objects, and it's equal and opposite for each force. So even though the masses are probably different, the force, believe it or not, is actually the same on each object. It's really one force that they share. This r is really the distance between the two objects. It's not a radius. It's the distance between the two objects. And you have to measure that from the centers of the two objects. All these things are going to come into play in the next problem. So here's the example problem that we're going to try to solve. This is a typical gravitation problem. You have a satellite above the Earth. Pause this, and if you want to, just give it a shot. Try to calculate the answer before I show you. So the first thing I've done, which I think is extremely important, is I've drawn a picture of what's happening here. And I've got the Earth and I've got the satellite. You have to take into account the radius of the Earth because you really want to know how far is the satellite from the center of the Earth. The radius of the Earth is 6,400 kilometers approximately, and this satellite is 8,000 kilometers above the surface. So if you think about it, the r, which is the distance between the two objects, it doesn't always mean radius, it's the distance between the two objects, is just the sum of those two. So the distance is 14,400 kilometers. But think about that. We don't want it to be in kilometers. Meters are the unit of choice in physics. So that's 14,400,000 meters. Now I'm going to write down, I've got basically all my information in the problem in there, but I'm going to write down the mass of the Earth, which I like to put in as a capital M, and it's 5.98 times 10 to the 24th kilograms. Mass of the Earth. And I'm going to write down the other mass, which I like to put in as a lowercase m. So I've written that down. Now, this is the same as writing m1, m2. It doesn't really matter. Now I'm going to plug into my equation. So you can try this too. And I'm going to write, and you can start calculating this if you think of, if you want to start familiarizing yourself with your calculator. So I've written down this entire plug-in. So I'm just going to plug into this formula. Notice that g outside the numerator, is the same as just multiplying across all these three. Then you're dividing by this number, which is going to be squared. Now I'll show you how to enter all those numbers in a common typical calculator. The TI-30X2S. So I type 6.67, and you're looking for that exponent button, and that's not to be confused with this exponent right here this little lowercase e to the x, you're looking for the double E button, which in this case is located right here, and it's going to be a second function. So I'm going to do second function double E. That means times 10 to the, I'm going to hit negative 11. 6.67, that E, again, this is worth saying over and over, that E stands for times 10 to the. It doesn't stand for 10, it doesn't stand for times, it's times 10 to the. Times 350 times 5.98. Again, I'm going to do second function double E, 24. Then I'm going to divide by, in parentheses, that number squared. 14,400,000 squared. Close parentheses, enter, and my answer is 673 newtons. Now let's see that on another calculator, the TI-30XA. This one's pretty tricky and kind of convoluted. I'm going to type 6.67. Here's my double E button, times 10 to the negative, I just pressed this button down here, negative 11, times 350 times 5.98 times 10 to the 24th. Now I have to redo that because it didn't hit the 20. This is what's annoying about this calculator. I can't undo that, so I got to start from scratch. 6.67 times 10 to the negative 11 times 350 times 5.98 times 10 to the 24th. Now I'm going to divide by a quantity in parentheses, and so I need to hit the close parentheses, and it knows that everything I'm entering now is in parentheses. 14,400,000. Now I'm going to square that, hit close parentheses, now hit equals, and it will finish dividing, and I again get 673. Now I'm going to do this on a sharp. I'm not very familiar with this one. We'll see what happens. I'm going to type 6.67. Here's my exponent button right here, EXP it's called. It's not a double E, it's an EXP. Times 10 to the negative 11 times 350 times 5.98, which is the mass of the Earth, times 10 to the 24th, divided by, in parentheses, 14,400,000. Now I'm going to square that, close parentheses. You can see the whole expression there, and that equals 673. Now I'm going to do it on the Casio. This is probably one I'm least familiar with, so we'll see what happens. I'm turning it on, 6.67. I'm looking for my double E. It's an EXP button, times 10 to the, and there's my negative 11 times 350. EXP times 10 to the 24th. I'm going to divide by a number in parentheses. Then I'm going to square that, close parentheses, equals 673.2. So the key to this strategy is knowing to put everything in meters, knowing what these variables really mean in this equation, especially R. What does that really mean? It means the distance from the center of the satellite to the center of the Earth. And being comfortable with exponents and order of operations on your calculator. Now, You try this one. Try this one and see if you get the answer of 4,409 newtons. Find the pull of gravity on a 4,600 kilogram meteor that's 14,000 kilometers from Earth. Thanks. Goodbye.